Hello everyone, we're here today to talk about Math 100, section 2.5. And for this section, it deals with formulas and applications from geometry. So first, let's define what is a formula. A formula is an equation that has a repeated real world application. And that is what a formula is. It has a repeated application. It's an equation that we can use over and over and over again. Now, let's look at these examples. It says, find the value of the remaining variable in each formula. So when we're dealing with formulas, we're going to be given an equation, and then we're given values. And there'll always be one we do not know. And let's take a look. Here, we're given A and L, but not W, right? So I'll plug in A is 64. Equals, let's see, L is 10, and then I had W, right? LW is the same as L times W, so I have 10 times W here. Let's see, how do I get W alone? Well, I can divide, right? I got to divide to get the 10 by itself. Well, when I divide there, I get, let's see, 6.4 equals W. When working with formulas, we typically like to leave our answers in decimal format, since it a lot of times might be easier for us to understand the real-world applications given the decimal format. Now, in our second example, we have a little more complex equation, but let's write what we have. Let's see, we have A, B, and H. Make sure you notice the difference, little b and big B, right? So I'll plug in 210 equals 1/2. Let's see, H is 10. So I'm going to put it in parentheses. And then parentheses, I have little b plus big B is 27. Now, I need to get this b by itself, right? I'm trying to solve for this value b. Well, to do that, I need to clean up this parentheses. First, I got to deal with this section out front, right? Before I can distribute in, I need to clean up out front, right? I need to clean up that multiplication. So that'll give me 210 equals 1/2 times 10. Is 5, right? Half of 10 is 5, which leaves me with b plus 27 in the parentheses. Now I am ready to distribute this 5 inside the parentheses, right? So I will have 210 equals 5b plus 5 times 27. It's going to be 135, I believe, but let's double check. Oops. 5 times 27 is indeed 135. Now we're entering more familiar territory, right? We're still trying to get b alone, right? So let's subtract 135 from both sides. That would be our next step, correct? And that'll give us 75 equals 5b. And now I can divide by 5 to get 15 is equal to b. So I know my answer is 15. Notice I just plug in and then evaluate. I plug in and then solve for the variable, right? I'm evaluating what is the value of b given the other values of the variables, right? Now let's take a look at this one. A backyard is in the shape of a rectangle. Well, the first thing I'm going to draw is a rectangle. Alright, a backyard is in the shape of a rectangle. The length is 5 meters less than twice the width. And we got to remember, we have a length and a width, right? We've got a length and a width on our rectangle. And it says the length is 5 meters less than twice the width. So length is 5 meters less than twice the width. So I'm going to underline all those keywords. Is an equal sign. So the length is 5 meters less. 5 less than means I need a minus 5 from whatever this is. I'm minusing 5 from twice the width. So the length is 5 meters less than twice the width. The length is 5 meters less than twice the width. So this is something the question has given me. And, well, we got an and, right? The perimeter is 80 meters, all right? Perimeter is equal to 80 meters. Find the dimensions of the yard. Well, I've got some equations given to me and some things given to me, right? There's also something I know. I know that the opposite sides are equal on a rectangle, right? I already know that the perimeter should always be equal to adding up all the sides, right? That's how perimeter works. It should be equal to 2L plus 2W. I know this equation is true. That's the perimeter equation for a rectangle, right? And I know some things about the values. I know the perimeter is 80. So I'm going to plug in 80 for my perimeter. So we'll get 80 equals, and now I have 2, and here we're going to be careful. We have L. I don't want L anymore. I want W. Notice I can turn L into W. I know how L is represented by W. I'm going to take this whole chunk here and replace L with that chunk. Because notice what will happen. I'm going to take that L and replace it with 2W minus 5. And I make sure I put parentheses because it's a whole group. Notice I turned this box into this box. Think of it like copy and pasting, right? And then I have plus 2W. Notice what happened when I used the parameters of my equation. I now have an equation that only has one variable in it. It only has W in it. I can now solve this equation. I can now solve this equation. And to solve it, the first step, hopefully we need to distribute, right? We got to get rid of these parentheses. Well, I have 80 equals 2 times 2 is 4, W. 2 times minus 5 is minus 10, plus 2, W. So I get 4W minus 10 plus 2W. I notice on the right-hand side, I've got some like terms, 4W and 2W. So I'm going to combine those. 4W plus 2W is 6W, and I still have a minus 10, and that should be equal to 80. Well, to get W alone, I'll add 10 to both sides. All right, I got to add 10 to cancel out that minus 10. Let's see, that gives me 90 equals 6W. Divide by 6, divide by 6. That tells me W is equal to 90 divided by 6 will be 15. So W is 15. So the W is equal to 15 meters. The units were in meters, so I make sure I put meters on my units. Now I also need to find the length, right? It says find the dimensions. I need to find the length. Well, the length is 2W minus 5, right? 2W minus 5. Well, W is 15. Let's see. 2 times 15 minus 5. The length is 25, right? The length is 25. And with problems like this, I always like to check. The perimeter is 80 meters. Let's see. 15 plus 15, adding the widths, and then 25 plus 25, adding the lengths to it, does give me 80 meters, right? So I know these dimensions here are the correct answer. Notice this question used the formula and a relationship between the dimensions to give us the actual dimensions. Make sure you understand that you can use known formulas and given properties to evaluate specific dimensions. Now, let's look at another one. It says, the longest side of a triangle is 3 feet longer than the shortest side. The medium side is 1 foot longer than the shortest side. And then, if the perimeter of the triangle is 16 feet, what are the lengths of the 3 sides? Well, first I notice I've got a longest side, a shortest side, a medium side, a shortest side, and perimeter, right? The perimeter is 16 feet, and the longest side, well, we can underline the relationship was 3 feet longer, right? And the medium side is 1 foot longer. So I'm going to draw a triangle with 3 different length sides, right? A long side, a medium side, and a short side. And then I'm going to write my 3 unknowns. I've got a short side, a medium side, and a long side. Right? let's see what we can apply here with variables. We have some unknowns, right? We have some unknowns, and we have one known, right? We know perimeter is 16 feet. So perimeter, you always add up the sides to get the perimeter. So I need to come up with variables for these sides. And I noticed that the longest side is referencing the shortest side, and the medium side is also referencing the shortest side. Remember, whenever you have three unknowns, you should always choose the one that's referenced twice as your variable. So I'm going to choose that to be my x, the short side. Now, longest side is 3 feet longer than shortest side. Well, this longest side will be x plus 3, because it's 3 feet longer. Now, the medium side is 1 foot longer than the shortest side. So the medium side will be x plus 1. I have all of my sides represented in the same variable now. I used the parameters of the question, right? Well, now, x plus 1 plus x plus 3 should be equal to 16, right? That's what we just said. The perimeter is adding up all the sides. I put parentheses in to keep myself organized, but I didn't need them, right? Everything's addition. It doesn't matter if you have parentheses when everything is addition. Addition is the only operation here, right? That's one of the properties of addition. It does not matter what order you add things in. So I'll look at my like terms. I've got x, x, and x. That'll be 3x. And then for constants, I've got 1 and 3. That'll be 4, right? 1 and 3 make 4. And that should be equal to 16. Well, to get the x alone, I got a minus 4 and minus 4. That'll give me 3x equals 16 minus 4 is 12. And then I divide by 3 and divide by 3, right? And that'll tell me that x is equal to 4. So the shortest side is 4 meters, equal to 4, I'm sorry, not meters, feet, right? Feet. This question was in feet. So the medium side, well, that must be 5 feet, right? How'd I know? It's 1 foot longer, right? 4 feet, 1 foot longer would be 5 feet. And then the long side, let's see, 4 feet, and it needs to be 3 feet longer. That'll be 7 feet, right? So my dimensions are 4 feet, 5 feet, and 7 feet. Which, if I check, 4 and 5 make 9, and 7 more is indeed the given parameter of 16. So it's always good to check that your actual dimensions match what they were supposed to match, right? So we have our sides of our triangle, right? Good. Now let's look at another example. This one says the area of a triangular sail of a sailboat is 126 square feet. So I've got area of a triangle, right? The base of the sail is 12 feet. Find the height. So, with triangles, let's say I draw my favorite triangle. They have a base and a height, right? Triangles have a base and a height. And I know some things. I know the area formula of a triangle is 1/2 base times height, right? That's the area formula for a triangle. 1/2 base times height. Now, what values did I know? I knew the area was 126, so I'm going to write area equals 126 feet squared. And the base is 12 feet. Base is 12 feet. So I don't know the h, right? Well, let's plug in what we have. 126 equals 1/2. The base is 12, and then we have h, right? I got to do 1/2 of 12 first, right? I got to clean up this multiplication before I can start moving stuff around. 1/2 of 12 is 6h. Let's see, I'll divide by 6. Divide by 6 gives me 21 is equal to h. So the height is 21 feet. How did I know it was feet? Well, we're measuring a height, and the question gave us feet as the dimension, right? So I'll keep the units as feet. So I found the height of my sail for my sailboat. Notice we had to use the formula here. Once again, we had to use the formula for the triangle, and then what we knew about said triangle. Now, we have one more topic to look at, and then a couple examples of it. But let's talk about solving a formula for a specified variable. So here's kind of a definition, but we have a solving a formula, right? A formula is said to be solved for a variable if that variable is isolated. So a formula is said to be solved for a variable if that variable is isolated. For example, area equals 1/2 base times height is solved for A. This formula is solved for A. On our first page, we saw area equals 1/2 height base plus base, the trapezoid formula, right? It is solved for area. It's solved for area. So a formula is solved if it is isolated. So for example, y equals mx plus b is solved for y, because y is alone, right? So we can isolate a variable to make an equation solve for it. And then how do we do this? We use our equation techniques, to do this. It works just like we have been. We use the equation solving techniques to do this. So let's take a look at what these look like. Let's try some. Let's look. Solve A equals LW for W. Well, I want to get W equals stuff, right? I need to get W alone. I need to solve this equation for W. Well, W is trapped with the L right now. So the first thing I'm going to do is try and get rid of that L, right? So I have A equals L. Remember, it's multiplication in between the L and the W, right? Since I didn't write an operation, it's multiplication. What's the opposite of times? It's divide, right? And if I want to get rid of the L, the opposite of multiplying by L is dividing by L. But remember, if you do it on this side, you got to do the same thing on this side. You have to divide both sides by L. So I'll be left with W on one side, right? And on the other side, I have A divided by L. Now, I don't know what A divided by L is equal to, right? I have no idea. I can't simplify that. That is simplest terms. This is the answer to the problem, right? I have it in terms of W now. A over L. I can't reduce that. Let's take a look at the next one. P equals 2L plus 2W for L. So my goal, I always like to write my goal first, is I'm trying to get L equals stuff. Right, I'm trying to get L alone. That's what it means to solve for L. It's currently solved for P, right? The perimeter formula for a rectangle is solved for the perimeter, right? Well, if I copy my formula down, the first thing I notice is I need to move this 2W over to the other side, right? I have 2W here that I don't really want. Well, the opposite of plus 2W is minus 2W, right? You want to think in terms of minuses. However, if I do it to the right side, I have to do it to the left side. Now, normally, when we move variables over, we line them up with the other W's on the other side, right? There's no other W's, so I'm just going to line it up over here and see what happens. I have an equals sign here. This cancels out and leaves me with 2L on the right. That's the only thing left on the right. What about P minus 2W? Well, I'm just going to write P minus 2W. I can't reduce that because those are unlike terms. They cannot be combined. So I will leave them separate. Now I'm nearly done, right? I have to get rid of this 2. To get rid of the 2, I need to divide by 2, right? I need to divide by 2. But I need to be careful. I divide everything by 2. I divide everything by 2 because that's the division rule, right? You divide everything by 2 when you're dividing. So I have to divide both of these by 2, not just one of them. Here, dividing by 2 cancels out and leaves me with L equals P divided by 2. P divided by 2 minus. So I had P divided by 2 minus, let's see, 2W divided by 2. The 2's will cancel for that one, right? And I'll just have minus W. So for the W term, it gets left by itself in the end, right? So I have L equals P over 2 minus W. Now, I don't know what P over 2 reduces to, so I will leave it like this. I cannot simplify anymore. I have no like terms to combine and no operations I can simplify. So I have completed the problem. In my next example, I have the area formula for the trapezoid, and I'm trying to get B alone, right? So I want B equals stuff, right? I want big B alone now. Well, the first thing I notice is there's some trickery going on out front, right? I have that 1/2. So I'm going to write A equals 1/2 H. And then what I'm going to do is I'm going to distribute the 1/2 H to both of these. I'm going to take this whole 1/2 H and distribute it to both little b plus 1/2 H big B. Because I now have all of my terms separate, right? I have an A term, a 1/2 H little b term, plus a 1/2 H big B term. Now, remember, once you've cleared your parentheses in a problem, you can use the trick with the fractions, right? I can look at the coefficients. I have the number 1 in front of A, right? I have the number 1/2 in front of my H little b, and I have the number 1/2 in front of my H big B, right? Now, I want to multiply these by their common denominator, which common denominator between 1/2 and 1/2 would just be 2, right? So I'm going to multiply everything by 2, which gives me 2. Let's see, 2 over 2 is 1, and 2 over 2 is 1, right? We've seen the trick clearing the fractions before, right? You multiply it by the common denominator to clear out the fractions. Because now, the 1 becomes a 2, so I'll have 2A equals, the 1/2 becomes a 1, so it'll just be H little b, plus, and the 1/2 becomes a 1, so it'll be H big B. So now I've cleaned up the fraction portion. Now, I'm still trying to get big B alone. First thing I need to do is deal with the H little b. Well, I'm going to subtract H little b from both sides, right? If I want to move it to the other side, I need to subtract it. And if I do it on one side, I got to subtract by the same thing on the other side, right? Here it will cancel out. And I'm going to flip which side HB is on now. We have H big B left, right? And then it's equal to 2A minus HB. These are not like terms, so I'll leave it separate as 2A minus H little b. Now, I'm nearly done. I have HB. I'm trying to get B alone. I need to get rid of this H, right? Well, it's multiplication currently, right? The opposite of multiplying is dividing. So I'll divide by H. But remember, you have to divide everything by H. That's what the division rule tells us to do. We got to divide everything. Well, in our first example, our first term, it will cancel and leave me with big B, like I wanted, equals 2A over H. 2A over H does not simplify at all, right? Minus HB over H. I have both H and H in the top and bottom, right? When you're dividing h by h, they will cancel, right? Just like when I divided 2 by 2, right? H by h will cancel, which will give me just little b left over. So I have big B equals 2a over h minus little b. And this is my answer. I have solved it for big B. Notice there were several steps I had to take in this problem, right? This problem had a lot to unpack. But the formula itself was a little messy to begin with, right? We had a lot to unpack before we could get to our answer. Now let's take a look at a couple more. Let's take a look real quick at 2x minus y equals 7. Well, I want to solve it for y, so I'm trying to get y equals stuff, right? I want to get y equals stuff. Maybe I remind myself that's what I'm doing. Let's see, 2x minus y equals 7. Well, the first thing I want to do is minus 2x from both sides, right? I'm trying to get y alone. Here it'll cancel and leave me with minus y equals 7 minus 2x. That doesn't combine, right? Those aren't like terms. Now, let's see. Negative y. I want positive y, not negative y. Because remember, there's a 1 hiding here, right? It's negative 1y when we have negative y. So I'll divide by negative 1. But remember, I got to divide everything by negative 1. I have to divide all terms by negative 1. That will leave me with y equals 7 divided by negative 1. 7 over negative 1 is negative 7, right? Positive over a negative makes a negative. Minus 2x over negative 1, that's a double negative, right? That'll be plus 2x. Notice it just flipped the signs, didn't it? It made the 7 negative and the negative 2x positive, right? That's what dividing by negative 1 does. Now, maybe you don't like that order. Maybe you want to write 2x minus 7 instead, right? You can do that, right, as long as you keep the signs the same. Either or is a perfectly fine answer. Both are fine answers. Most times we like to put the x first, but the other one is just as valid of a correct answer. These equations are equivalent, right? And they're both solved for y, right? Let's take a look at the next one. We got minus 3x plus 2y equals 6. Well, I got to get rid of this minus 3x, so I'm going to add 3x to both sides. Add 3x to both sides. Let's see, that leaves me with 2y equals 6 plus 3x. All right, 6 plus 3x, right? I can't combine those because they're not like terms. Then I'll look here. I got 2y, so I got to divide by 2, right? But remember, you got to divide everything by 2 because that's the division rule. 2 gives me, let's see, y left over there. 6 divided by 2, I know that's 3, right? Plus 3 divided by 2, that doesn't simplify beyond 3 over 2, right? That fraction is already reduced as much as I can. So I'll just leave it as 3 over 2x. So I'll leave the 3 halves as it was, because it doesn't reduce, right? I always want to reduce, but that's as far as it reduces. And now I would be done, right? Similarly here, you could write y equals 3 halves x plus 3 instead, right? The order is totally aesthetic, right? As long as you keep the signs the same, you can move your x term in front if you want, right? They're both positive, so I just keep them both positive, right? Here I had to be careful that the 7 was still the negative one, right? It's still being subtracted, right? And that is section 2.5. Thank you all for joining me, and I will see you next time.